Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we have new concepts about reflection of light, paper 3 core candidates. We have classwork. As usual, you have to read the specifications, you have to download or get the KWL chart if you join the Telegram channel, and write here what do you know, what you want to know, and at the end write what you learned. Okay guys? Okay, if you would like to share the KWL chart, follow the Instagram, and you can have some new experience about what your colleagues they wrote and what they got. Okay? Okay, let's start by question 1. Okay, let's use new color. Okay, question 1, showing here a ray of light striking a plane mirror. State the name given to angle X. Okay guys, you have to follow the arrow. You have to follow the arrow. Here, this arrow means incident light ray. Striking the plane mirror, reflected back. So here, this will be the reflected ray. Okay, so the angle between the reflected ray and the normal, this is indicating for the angle of reflection. What do you mean by normal? It's a construction line, as you see here, construction line, dotted line. Okay, help you to locate the angle of incidence and angle of reflection. Okay, it's at right angle perpendicular to the reflecting surface, perpendicular to the mirror. Okay, state the name given to this angle X. So it's not the angle of incidence, it is the angle of reflection. Okay guys, part B, you have the figure showing incorrect ray diagram for an image of object O formed by plane mirror. So here you have the object and the light rays incident here striking the mirror should be reflected obeying the law of reflection, which states that the angle of incidence should be equal to the angle of reflection. Clearly mark the correct position of the image and label this I. Okay, using your ruler at equal distance behind the mirror, you have to draw so this will be the location of the image. Okay, I. So as you see now, the extension of the reflected rays, here we have these are reflected rays. So the extension of the reflected rays, they should meet or intersect at a point which will be the position or the location of the image. So this is the point which is incorrect. So number 1, he's asking you explain why the ray diagram is incorrect. What's wrong here? You have to mention that number 1, the image is not in front of the object at equal distance behind the mirror, and this, if you draw here a normal, you will find that the angle of incidence and reflection, they are not the same. If you draw a normal, you will find that they are not the same. So the object and the image are not at the same distance, and angle of incidence is not equal to angle of reflection. So you have to write these 2 points here. So number 1, you have to write that the image and the object are not at the same distance from the mirror, and the second point, that angle of incidence is not equal to angle of reflection. So these are the 2 points which representing the mistakes, or why it's drawn like this, what are the mistakes in this diagram. Okay, since we have here a classwork, I have to tell you very important point. We have letters of the word lost. We usually use these letters, lost, or the word lost, in reflection, and later on we are going to discuss thin converging lens. We will discuss how the image will be formed. These words, this word, okay, the first letter of other words, which are location, orientation, size, and type. Okay, location, which means where the image is located, behind the mirror, at a certain distance, what is the location of the formed image. Orientation, as in our case here in the plane mirror, it is laterally inverted, so location at equal distance. Orientation, laterally inverted. Right appears left and left appears right. Size, it will be same size. Okay, type, it's virtual. What do you mean by virtual? Formed by extension of rays and cannot be received on a screen. Okay, so if we have here any reflected rays, they should be extended. So the correct reflected ray here, for example, will be like this. So its extension will lead you to the position of the image. Okay, let me draw it by a ruler so it will be reference for you. Okay, so the reflected, so if the image is here, the image is here, so the reflected ray, so here we have the reflected ray, its extension will lead you to the position of the image. Okay, guys, let's move to question 2. Question 2, here we have 2 parallel plane mirrors and a ray of light strikes mirror A at an angle 45, and you have here state the name given to the angle X. Okay, angle X, here you have here the incident ray, and here the reflected ray. So angle X is the angle between the reflected ray and the normal, so this is the angle of reflection. Okay, what is the value of x and y? Okay, x will be the same as the angle of incidence according to the law of reflection, so it's 45 degrees. Okay, these two mirrors are parallel to each other, so mathematics is the language of physics. Tell me your mathematics skills. What's the relation between x and y? They are alternate angles, so they are equal, so it will be also 45. Okay, so angle x and y, okay, you see this z. Okay, so these two angles are equal to each other. Okay guys, on this figure, use your ruler to draw the path of the ray after it leaves the surface at B. So what happens at B? It will be reflected by the same angle. So this ray will be somehow parallel to the first instant ray. Okay, so it will be like this, reflected by the same angle of incidence. Okay, so this will be the reflected ray. Okay, okay. The last part, the mirror B is now rotated so that it reflects the ray back along its original path. How it will be reflected along its path? It means it strikes the mirror at right angle along the normal. So how can you draw the mirror now? You will draw the mirror perpendicular to the ray. So the mirror will be like this. Okay? To differentiate between normal line or ray or whatever, you have to draw these shaded lines to indicate this is a mirror. Okay, so the ray here is incident at right angle to the mirror. What happens? It means it's along the normal. So if you also draw a normal line here at right angle to the mirror, what happens? What will be the angle between the incident ray and the normal? The angle between the incident ray and the normal, in this case, angle of incidence will be equal to 0. Angle of reflection also will be equal to 0. Why? Because the ray will be reflected back along its path. So the ray will be reflected in this direction. Okay, so the incident ray and the reflected ray, they are along the normal, and the angle of incidence and the angle of reflection will be 0 in this case.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.